Hello, everyone. We are here today to talk about AI-enhanced development from local to cloud-scale machine learning. My name is Khushbu Srivastava. I'm a product manager on AWS. I'm the PM for IDEs, notebooks, SageMaker Studio in Amazon SageMaker, and I'm passionate about democratizing AI. Along with me, joining is my colleague.
Hey everyone. So I'm Pooja Karadgi. I'm also a senior technical product manager with SageMaker AI, and I lead product management for SageMaker Jumpstart Model Hub as well as SageMaker Studio experiences.
A quick look into the agenda for today. We will talk about AWS vision. Then we'll move into taking a look at notebooks innovations in AWS, new features and open source updates. And finally, we will talk about our key SageMaker offerings, SageMaker Studio and SageMaker Unified Studio. We believe that generative AI is one of the most transformative technologies of our generation. So we want to make AI accessible to every learner, developer, and data scientist. AWS is committed to empowering every user in their AI and open source journey. Now, a quick look into the timeline for innovations for notebooks in AWS. Given the importance of Jupyter to data scientists and ML developers, AWS is an active sponsor and contributor to Project Jupyter. Our goal is to help Jupyter be the best possible notebook platform for data science and machine learning. Here's a quick look into the timeline. In 2017, we launched SageMaker Notebook instances. SageMaker Notebook instances uh, are a managed offering that come with their own compute and storage. You can provision and spin GPUs and CPUs in minutes. A lot of our early adopters, as well as enterprises, love notebook instances because it provides an easy way for you to prototype and experiment. In 2019, we launched SageMaker Studio Classic. SageMaker Studio Classic is a web-based end-to-end ML development platform. It's built on top of the Jupyter IDE. In 2021, we launched Amazon SageMaker Studio Lab. Studio Lab is the free offering that AWS provides. Any beginner, any machine learning enthusiast can go and use Studio Lab for quickly creating and developing machine learning workflows, all free of cost. You don't even need an AWS account to do so. It provides support for free GPUs, CPUs, and storage, all easily available via web-based interface. In 2022, we launched the new version of SageMaker Studio. This new version comes with a next generation notebook support. SageMaker Studio is IDE agnostic. As a data scientist, you can pick any IDE of your choice. You can pick code editor built on open source VS Code. You can pick Jupyter Lab IDE. You can prepare your data workflows. If you have Spark workflows that need to scale and need more power, you can even integrate with EMR clusters. You can bring your own model. You can pick from a registry of foundational models. You can train, fine-tune your model, deploy, manage, and monitor them all within a single platform. A web-based interface that makes machine learning development very easy for you. In 2023, we launched a number of usability improvements and Jupyter extensions that we will see in a bit. And finally, in 2024, we launched SageMaker Unified Studio, which brings all the AWS data, analytics, and AI ML services under a single platform. Let's talk about Jupyter Deploy. Jupyter Deploy lets you go from your local machine to cloud deployment using just a single CLI command. It abstracts away all the technical complexity while you stay in control of the deployment. It is secure, and you can collaborate with your distributed team members in real time. It provides infrastructure at code templates. You can contribute your own templates and scale your notebooks, your compute and provision GPUs in matter of minutes. Please see the GitHub link and the QR code if you're interested in learning more about it. SageMaker distribution. At AWS, we call SageMaker distribution image as the golden universal image, and there's a reason for it. It is a pre-built Docker image that contains all the popular packages that you need for machine learning, data science, and data visualization, such as PyTorch, TensorFlow, NumPy, scikit-learn pandas, JupyterLab, and other IDEs. It standardizes runtime between your local machine and cloud infrastructure. It can run on SageMaker Hyperpod, Studio, Amazon EKS, and your local machine. Key thing to note is that it abstracts away all the complexity that is related with conflict management, versioning, if you want to provide bug fixes, security fixes, it's all managed for you. So you can focus on ML development. JupyterAI. For AWS, it's really important to ensure that we are constantly making progress towards improving our developers' productivity. And a key way to do that is the support for JupyterAI. In 2023, we launched support for natural language assistance, code generation, code debugging, explanation that could really help improve developer productivity. But now we're also introducing collaborative chats and AI personas. You can create more than one chat. You can save your chats. You can share your chats with your team members. You can also invoke AI agents or AI personas in these chats by simply @ mentioning, just like you would do it in your Slack or GitHub. Now I'll give the mic to my colleague to talk about further enhancements.
Thanks, Kushbu. It's amazing to see how AI is natively integrated in these notebooks, allowing us all to experiment, write, and debug code, improving our overall productivity. But even with all of this AI enhanced coding, one problem still remains for a lot of us: getting and managing the data that these notebooks rely on. For most of us, this means that our data usually lives in some form of cloud storage, like S3. But the data could be spread out across multiple different buckets, across multiple different teams, and different regions. That's where Jupyter Drive comes in. It's a native S3 browser for JupyterLab. It allows you to browse, view, and manage all of your S3 buckets on the single JupyterLab notebook interface. You don't have to leave your notebooks in order to view the S3 buckets where your data resides. Installing is as simple as installing any other Python package using pip install Jupyter drives. And when you do that, you'll be able to see an S3 bucket on the left-hand side navigation. When you click on that, you'll be able to see all the S3 buckets that you have access to. You could view the files as well as folders inside each of these S3 buckets. And again, it's all available in a single notebook interface. You don't have to switch your browser tabs or go to different browser consoles. Okay. Yeah. Okay, now you built your perfect notebook, either using JupyterAI or the other capabilities that Kushbu spoke about, or using Jupyter Drive. But what next? Maybe you want to use these notebooks and you want them to run on a weekly basis, a daily basis, or whenever new data is available. That's where the next piece of puzzle comes in, called notebook scheduling. Notebook scheduling is again a Jupyter extension that allows you to run notebooks as SageMaker jobs directly from JupyterLab. Once you install it using pip install Amazon SageMaker Jupyter Scheduler, you will see a screen that you have here. You can configure the cadence on which you want to run the notebooks on. You could also choose to run them on demand or set up a specific schedule. When you do that, it runs based on the cadence that you chose. It also integrates monitoring, so you can check the log outputs or the job outputs or job statuses right inside Jupyter Lab Notebook. In short, the notebook scheduler helps you take that AI-powered, data-ready notebook and turns it into a repeatable, production-ready job. Next, I want to talk about the remote decorator. Imagine you have a Python function. You have tested it locally with your own local data sets. You have tested it with your CPU or GPU instances, whatever was available, and now you know that it runs perfectly fine. And now you want to scale it. But again, you don't want to rewrite all the code. You don't want to manage all the dependencies. Enter the remote decorator. Remote decorator is a Python function annotator. And when you specify that for any Python function, the SDK internally takes care of packaging your code, managing all the dependencies, and then running that as a SageMaker training job. In essence, you keep your local workflow, iterate on your code, test locally, and when you're ready to train at scale, you simply switch the decorator and hit run. Note that even with this remote decorator, you're still able to specify the instance types on which you want to run, also the IAM role and other job settings. All of this is still configurable through the remote decorator. Next, before I talk about the two capabilities that are very specific to SageMaker Studio and SageMaker Unified Studio, let me very briefly introduce the products. Both SageMaker Studio and Unified Studio are integrated development environments that allow you to do end-to-end machine learning. You could select your preferred IDE, which includes Jupyter Lab. You also have the choice of code editor, which is based on open source VS Code, or RStudio. You could choose your IDEs, then you can prepare the data that is needed for training or fine-tuning of these models. When it comes to preparing data, you could either do it in your notebooks using the SDK, or you could use any of the available tools in Studio and Unified Studio. After you've prepared your data, the next step is selecting a model. SageMaker Studio and Unified Studio come with 1,200 plus models through SageMaker Jumpstart Model Hub. You could select a specific model and then either choose to fine-tune the model or directly deploy the readily available model. Again, fine-tuning and deployment can be done through SDK in notebooks, or we also have a very easy-to-use user interface which allows you one or two-click deploy. Once you deploy the model to production, the next step is managing and monitoring the model. Both the platforms allow these capabilities to make sure that your production endpoints work as expected. With that introduction, I want to talk about a powerful capability called remote access. With remote access, your Jupyter Lab workspace and compute would live in the cloud, but you can connect to it using your local machines. The advantage, it helps you with your familiar development environment. You could continue using the tools and extensions that you're so used to using while still benefiting from the scalability, security, and managed infrastructure of SageMaker Studio. From user's perspective, it's very simple. You go to SageMaker Studio, you toggle on the switch there, which is remote access. Once you do, you'll be able to see open in VS Code. When you click on that, what essentially happens is it connects to the remote Jupyter Lab IDE, which means you could continue using the configurations that were set up by your admin or the file system that was configured in your Jupyter Lab remotely. But all of the logging, monitoring, etc. in your VS Code happens as if you were working locally. There's one more capability I want to highlight, and this is especially for teams that work with very diverse data workloads, called multi-engine notebooks, where a single Jupyter notebook can run multiple compute engines. You can mix Python, Scala, PySpark, and SQL in the same notebook using magic commands. This means your transformations, analytics, machine learning, and all code can live side by side without you having to bounce between different notebooks or different tools. You also get flexible control over your compute and connection. You'll be able to see a drop down which allows you to choose your compute engine, like PySpark, SQL, Scala. And your workflow stays consistent without repetitive configuration because all of these settings get inherited to the next set of cells. And the best part, you can access all of your data sources like Redshift, Athena, EMR, Glue from one single interface. All of this brings cloud data into a single Jupyter workspace, letting you focus on analysis rather than plumbing. That's all we had. So go ahead, experiment, build, and scale. Thank you, and we can't wait to see what you'll build with these capabilities.
Thank you,
Thank you.
everyone.